Welcome to the presentation. This is Challenge 17, Team Gradient Descent. This is our automated WBS planning for Crossrail 2.
These are the gradient descendants: Daniel, Anand, Dhruv, Gabriel, Prithvi, and myself, Arjun. Challenge summary. The idea was to create an automated model to predict or create a work breakdown structure for Crossrail 2. One of the major pain points of this challenge was the limited similarity between the different data points available. The idea was to create a standardized work breakdown structure using all this non-standardized work breakdown available to improve the efficiency.
Input data. Here is a quick visualization of the data we have had to use. The map on the right is showing the various different stations that could be used in the future for this project, and the left, up and above and below, show the two data frames, one in Note and the other in JSON. Concept idea. Initially, we took the JSON files and converted them into CSV files, which is a more readable state for Python. From here, we collated all the files into one CSV file for the model. We used this to create the Python data frame. After this, we used lemmatization process to collate similar words under one source word for each chosen level, with level 0 being more simpler, and level 4 being more granular and detailed. Then we used the market basket analysis to find the most frequently associated words.
So market basket analysis, what is it? It's an algorithm that is often used on transactional type of data. However, it can be utilised for data whereby you are trying to ascertain the associations between certain variables. This is why it is predominantly used for recommendation systems that you might see whilst shopping on Amazon or being recommended a new show on Netflix. The algorithm can also be used for the purposes of prediction or differential analysis, where you are trying to find differences between datasets and their associations. We use the following association rules as a guide for analysing the associations. We have support, which is looking at the fraction of which our item set occurs, or in this case, activity, within the WBS. Then we have confidence, which is the probability that an item is likely to be associated with another item. Finally, we have lift, which expresses the ratio by which the confidence of a rule or association exceeds the expected confidence. Now, that might seem a little bit too complicated, but for the purposes of this project, we simplified it and we just focused on interpreting the confidence rule. Therefore, whichever association has the highest confidence value, being 1 or 100%, then we would use that as our guide. So, what were we able to produce from this data? We were able to test the model and provide a WBS for Crossrail 2 based on previous data provided. We have kept this model very simple as a way to demonstrate a proof of concept that has the capacity to easily scale based on increasing data. We can also improve the recommendation logic of the model if we increase the amount of data. For the purposes of this project, we decided to build out 3 levels for the WBS based on previous data. We thought this would make things very simple. So let's look at our outputs and what we found. So starting at level 1, we found that for our WBS, stage completion would be the best place to start. We started using popularity as this was the best way to go. After this, we were able to then conditionally provide to our model what would be the best association related to stage completion. Well, what we found was, based on stage completion, for level 2, SC3 ROGS was the next best step. Finally, for level 3, using both conditionals of stage completion and SC3 ROGS, we were recommended that ECHR was the last and final step that would be most recommended for the output of this model. So, how would you be able to do this for yourself in an open source and easily distributable manner? I'm so happy you asked. Well, we built out an app that I can demonstrate to you now. Simply upload your WBS using the JSON file type. Then underneath you can specify the parameters of the levels which you are interested in finding close associations of. You can already see how it has started to populate the network graph on the right-hand side. This is illustrating to us closely associated items based on the dataset that you just provided it. It is a great tool for exploration or supplementing your insights as you generate a new WBS for future. Judges' questions. All WBSs are constructed differently and for various reasons. Often an equivalent WBS in two different projects will sit at different outline levels. Does this data model take this discrepancy into account, and if not, how would you approach this given more time? Great question. Given the time constraints, the model is not able to identify equivalent WBSs in different levels, i.e. level 3 is equal to handover, and then level 4 of that is commissioning, which would also be the same as level 2 being handovers and level 3 in commissions. While slightly different, they're semantically exactly the same. But without a translation table built manually and with people with expertise and context, we could not fit this in the current iteration of this model. However, with the addition of this translation or reference table, the model would improve greatly. Question 2. Does your data model consider the presence of any redundant activities included in historical WBS data provided, and as part of its automation, utilize only the as-built activities? What we did was remove redundant features that were of low frequency. Therefore, using our automation and low frequency analysis, we were able to base this off popularity and therefore come to a consensus. Final question. If it was available, what additional data do you think would best improve the utility to the model and maximize its potential for producing realistic schedules? If we had more data, then that would equal better predictions. We would improve feature, size, value, and work type, and then this would create customized predictions